Hello everyone, so today we're going to solve the third problem of July Cook-Off Good Chef challenge. So this is the third problem of division 2 and the question is segmentation fault. So in this question we have been given, so let me open the question. Yeah, we have been given that there are n people from 1 to n such that exactly one of these people is thief and always lies. Okay, so exactly one of these people is a thief and he will always lie, and all the other are honest and always tell the truth. If the ith person claims that a thief is one person of L to R, so any person will claim that thief can be in between the range L and R. So that person can either be a thief or either be a truthful person. So thief is always going to lie and other persons are always going to tell the truth. So the truth is that truth they are going to say is that thief can be in, so thief should be in between L and R, and the thief is always going to lie. So thief will never going to let himself come in this range. So determine how many peoples can be thief. So currently all of these peoples are going to tell that whatever they think thief could be in between the ranges, and n minus 1 persons, so thief is going to be one person, other n minus 1 person, whatever range they states, thief is going to be in between that range. And so just to state that what I am saying is thief is 1 and will lie. Alright, so thief is 1 and will always lie. That means that thief will never never give himself in its range. So thief will never going to give himself in its range. So whatever the range thief is going to give, he is not going to include himself in that range. Alright, so n minus 1 person tells truth. So n minus 1 person are telling us the truth. Okay, so that means that n minus 1 persons are going to point at the thief. Alright, so n minus 1 persons are going to point at the thief. So to solve this question, let's us first simulate the example we have been given. So in this example there are a total of 4 persons and the first person is pointing at the second person. So this is it, and the second person is pointing at the first person. The third person is pointing at all of the persons in the range 1 to 3. The fourth person is pointing at all of the persons in the range 1 to 3 as well. So if so it will become something like this: 3, 3 and 2. Okay, so wait, not 3, 3, 2, so 1, 1, 1, I guess, yeah, 3, 3 and 2. Okay, so this is it, and the thing is that like these three are nothing but the people who are total number of so like bad value of 1. So like these are the claims, there are total number of 3 claims that 1 is going to be the thief, and these are total number of 3 claims that 2 is going to be a thief, and there are 2 claims that 3 is going to be a thief. So if n minus 1 persons are always going to point at the thief, that means that in this case n minus 1 is equals to 3. So 3 persons are always going to lie at the thief. That means that these 2 persons can be thief. We have given one more condition that thief will never give himself in its range. So the first person has given the range 2, 2. That means that first person is not including himself in its range. So first person can be possibly a thief, and second person is also giving 1, 1 range. So 1, 1, like both of the conditions are satisfying, that 1, 1 has total number of n minus 1 persons pointing at him, and so the second person has n minus 1 person pointing at him. Also the second person is not pointing at himself. So these two are our prime suspects, so we are going to print them, and if we look at our solution, they have printed them. Now to think of this thing like how to make this range. Okay, so they have also given us this range. So to make this range, like the brute force solution would be that if we have been given 2 2, we will go in this range 2 2 and will like add value there. Okay, and also goes for 1 3. So brute force will look something like this. All of the values initially are 0. We will go in the range 2 2, will increment the value. Then we'll go in the range 1 1, will increment the value. Then we'll go in the range 1 3. Will increment each of its value. So it will become 2 2 2, and this is going to be 0 only. So this is going to be 1. All right. So another increment has been asked by the fourth person. So this is going to become 3 3 and 2. So this is the brute force solution, and this ranges could lie from 0 to n. So this will like cost us a total of n square time complexity. We can reduce this to big O of n by like directly calculating this array. Alright, in big O of n. Instead of using n square, we can directly calculate it in big O of n. How we can do that? We can do that in like such a way that let's say first person is saying that it will point from 2 to 2. Okay, it is pointing from 2 to 2. And second person is saying that it is so let's first talk about 2 and 2. So in 2 and 2, let's just say that he is saying 2 and 3. Why? Because we are going to include the second person and we are not going to include the third person. So let's make 5 person. This person is just for show. Okay, we are not going to use the fifth person, but it is just for show. And we are going to do it in an array. So let us take the 0th element as well. So initially, like we have this array, and our first element was 2 and 2. So we are taking it as 2 and 3, and we are saying that it is going to start from the index 2 and it is going to end at the index 3. And it just basically means that we are going to include the person at index 2 and and we are not going to include the person at index 3. And our another so the second person is saying that 1 and 1. Okay, so we can say it 1 and 2. We are going to include the person at the index 1. We are not going to include the person at index 2. Okay, the third person is saying the range 1 3. We are going to take it as 1 4. So 1 will become 2 and 4 will become minus 1. The last person is also saying 1 3, that will become 1 4. So this will become 3. This will become minus 2. Okay, now if we take the prefix sum, it will become 0 3 3, and if we subtract this value as well, this is going to become 2 and 0 and 0. So this is the array that we desire. So this is the array that we desire, and we can just iterate through this array. We can also keep a track that whether the person is pointing to himself or not. Okay, so we can also keep a track of that as well. And yeah, so similarly we are going to just solve this sum. So let's look at the code for this sum. So initially what I am doing is I am taking the integer n, total number of persons, and after that I am making a vector a. So our vector a would be of length, so initially we have only 4 persons, but this array is of length 4 plus 1. So I am making a array of length n plus 1 n plus 2 and initializing all of the values by 0. Also I am making an unordered map of innocence. So innocence is just going to store that whether a person is pointing at himself or not. If a person is pointing at himself, that means that that person is definitely innocent. That's why I am using this map, and this is going to keep a track of that only. Now I am iterating through all the person and I am asking each person their respective ranges. So this line is going to ask for ranges, and in the next line I am checking that whether that person is including himself or not in that given range. If the person is including himself, that means that that person is innocent, and I am not going to include this value. So I did this here. After this I'm incrementing this value, the start value, the left value, and I'm decrementing the left value. So I'm decrementing the left plus 1 value. So I have decremented this value, I have incremented this value, and after this loop, after asking for queries from n person, what I'm doing is I'm like taking this prefix sum. So in this line we have taken the prefix sum. So I'm taking prefix sum. After this I have like made our vector answer, and after making the prefix sum I will run a loop through this prefix sum. So I'm running a loop through this prefix sum. We have basically two conditions. N minus 1 persons are going to point at the thief. So I am initially checking off both of these conditions, that if like n minus 1 person is pointing at a person, also that person is not innocent, we have not found that person innocent yet, then we are going to, if both of these conditions are met, then we are going to push back that person to our answer. And at the end we are just printing size and all of the suspect persons. So if we look as well, this is like submitting fine. I have submitted it just now. So I cannot find it, so let's just submit it again. So this is like the solution, and we can directly submit it from here. So this is going to get solved, and we are doing this in big O of n. So our solution is big O of n, so that's fine. Let's look at the solution. It is currently running on test case 4. So yeah, so it is giving us correct answer, and time is like very less. So they have not giving us how many test cases they are trying on, but we have done it. And if you have any other doubts regarding this question or regarding any concept, you can pin down those doubts in the comment. So yeah, so and if you have watched the video till now, please don't forget to subscribe to my channel and also like the video. Okay, so thank you.